welcome General Manager of Cloudera's machine learning business, Hilary Mason.
Thank you. Good morning, everyone. I hope you're ready for another exciting day here at DataWorks in Barcelona. I'm pretty excited to be here to talk indeed about how we make machine learning and AI boring. And in this talk, I'm going to talk about some of the challenges and opportunities we see, how we see people doing this well, what businesses really need to understand to get there, the state of the art for tech here today, and what we're building at Cloudera to help. Now, we can see all kinds of headlines about how AI is changing the world, AI is taking the jobs. Sometimes they're really positive. AI is rapping like Kanye West. But really, what substance do these have? We need to move our conversation away from being fascinated with the technology to thinking instead about the value of the outcomes that we're able to create with it. Now, the reality is that AI and machine learning is all around us today. We're all using it and taking it completely for granted. My favorite example of this is your email spam filter, right? This is a technology that every single one of us here uses without thinking about it. But also getting driving directions. Those apps are now so good, we use them even when we know where we're going. That's quite an accomplishment. Getting our weather predicted. You can even buy an AI-enabled toothbrush, which helps you do something, prevent issues in your dental care, right? This is everywhere already, and that is only going to expand over the next few years. And it might seem a little bit odd to talk about AI so much at a conference that's primarily about the management of data. And so let's spend a minute and think about how all of these pieces fit together. 10 years ago, we had a huge step forward in what we could do around big data, which was essentially an enabling set of capabilities that let us get all of our data in one place and count things in that data in a scalable, maintainable, and secure way. And this enabled companies like Cloudera and Hortonworks to start to create value. Now, when you can do that, when you can count things in your data, you can count things for a business purpose, and you can do analytics, and you can do business intelligence. And when you can count things, you can start to count things cleverly. And here's where we're able to predict and to think about inferring things that we can't necessarily observe directly in data, and this is data science. And then when we predict things, or we count cleverly and we build in feedback loops, now we have the ability to do machine learning and AI as a subset of techniques in that world of machine learning. And so all of these things really do fit together because they are built on the same platform, the same data, which is now enabling new use cases, new opportunities, and they have to work together seamlessly. So what does boring AI look like in the enterprise? Well, here's one of my favorite examples from a bank that we work with. This is a bank where they have improved their call center cost efficiency. They did it by getting call records, so speech to text, for an entire year, thousands of calls into their call center. They clustered those records to understand the things that people actually call in about. They looked at the actions that were taken, the things that actually solved the problem and the things that didn't. They combined this with data from all of the other touch points they had with customers through marketing, through using the website, through help, through prior calls. And then they were able to build a system that integrated for their customer service agents so that when someone calls in, it's transcribing that call in real time. It's trying to figure out what they're calling about based on that and other data about their interactions, their recent transactions. And it's making a recommendation, so a recommendation system to the customer service agent as to how to solve their problem quickly and efficiently. It allows the customer service agent to say, no, it's actually this other problem, and here's what I did. And that data feeds back into the entire system. This is very boring. Nobody loves call centers. There's actually not even any deep learning here either. But with simple mathematics and being able to get all of the data in the right place and to get one system to feed into a downstream system, they saved an incredible amount of money and, much more importantly, made their customers much happier by proactively reaching out to them before they had a problem to solve it. That is a boring example of AI and machine learning at work. And we see our customers in the enterprise, once they have that kind of success, where they manage to save money, have clear ROI, able to then invest in new business opportunities and new revenue opportunities that might be driven off that data. Another example here is from State Street Bank, building a new app called Veris to enable commodities traders to better access information to make better decisions. And the challenge we see today is really not one of being able to do this work at all. Today in 2019, most companies are able to do it, but they're doing it in pockets. They don't have consistency across their organization. Today's challenge is really about industrializing this capability, making it work consistently at scale, available to every line of business and every group that can benefit to it, figuring out how to invest in it, and having a single technology workflow that supports all of that throughout an organization. So when we talk about industrializing AI, that's what we're talking about, being able to repeatedly develop and deploy machine learning capabilities at the scale of your organization. And today I'm going to show you some of what we're doing around that at the moment, and then try to predict the future. But predicting the future is hard. So these are some postcards from France from 1900. They were trying to predict what the year 2000 would look like. And so you can see they got it more or less correct. So over here we have machines that are doing farming and agriculture. Again, we have this, right? They nailed the problem statement, the implementation, a little bit off. We have what is essentially Wikipedia here, except again, wired connections into the children's brains to help them learn. And here at the end, of course, we have advanced firefighting technologies to put out fires at the top of buildings more efficiently. And the point I'm trying to make by sharing this is that we're at the point today in AI where we can clearly define the problem statement, but the specific solutions we come up with still may need a little bit of those details figured out. So let's industrialize AI. Practically, we see 4 dimensions that must be considered in doing this well, and I'm going to talk through each of them in a bit more depth. Starting with strategy, most people approach machine learning and AI as if it is another IT project or another software engineering project where you can write a spec, assign resources and costs, and expect an outcome in a reasonable amount of time. But of course, this is still a science. It really doesn't work this way. Instead of creating a 2-dimensional scatter plot with time to benefit and value to business, and then sort of plotting everything and picking projects, you need to think of it as a multi-dimensional problem space where everything you invest in changes the cost function for everything else. We want to take this from being a science project to being an engineering project. And if you're curious about this, there's an article in the Harvard Business Review on how to select projects to work on that's comparing an excellent data science strategy with a mediocre one. But it's not as straightforward as it looks. You also need to do this in the context of security, governance, and compliance. And to many data scientists and creative technologists who are plugged into this process, those tend to be dirty words because they are generally framed as a process that they see as inhibiting innovation and inhibiting progress. But when this is done well, when we're not just shoehorning AI and machine learning into existing risk processes, it actually becomes an enabler of better quality work. And we are still developing a consensus on how to do this well, and how to do it well in specific regulatory contexts. And again, a book you can check out on ethics of data science for practitioners. Most people in our field are quite concerned with this topic at the moment, and it's one that's definitely worth a bit of time. And of course, there are always challenges around people and organizations. So I hear all the time we can't hire data scientists, and yet at the same time, you probably have people in your organization who would love the chance to engage in training to become data scientists. But are they managed the right way? Are they sitting in the right place? Are they centralized? Are they federated? Are they both? And there's no one right answer. So every decision you make to optimize for one thing ends up creating friction for another. And today, lots of people do this well. They all do it differently. And there's as much an element of complexity in transforming people and management and process as there is in technology. But we do firmly believe that AI is a team sport. And today, much of our tooling and the way we practice in our process is really about a lone person sitting at their desk with their headphones on, not talking to anybody, working in their own laptop in their own environment. But really, we will succeed when the more people within an organization who participate in the process create more value for their peers. This really is a team sport. So let's talk about technology and the scale of technology. A platform for industrialized AI has to provide a set of capabilities across an entire organization in a unified workflow. We have to make teams more productive in ingesting data, developing models, exploring data, exploring different approaches, hyperparameters, building their pipelines, and collaborating with peers so that they're not reproducing work that's already been done somewhere else in the organization. You have to train models, which means scaling resources effectively, tuning parameters, and tracking the performance of those models over time. You have to deploy those models with many different deployment targets into batch, streaming, reporting, et cetera, and figuring out how they get maintained. These systems are not done the moment you deploy them. They are living systems that must be maintained and monitored. And all of this has to be managed against a common data architecture that supports the security and governance requirements of the organization and that scales effectively with usage. And today, everybody who does this very well does it differently. So many companies have developed their own homegrown workflows. You cannot copy and paste from one to another. But there are a few general principles that we feel are important, including secure access to that data, access to those compute resources, and in machine learning, you often require bizarrely asynchronous compute resources, so perhaps many GPUs to train your model, but you can deploy it into the edge. Self-service research and exploration, so we need data scientists to not have to pick up a phone. Believe me, we do not like the telephone. To call someone else to get access to data that they should have the right to access for their work. We need a collaborative environment, and we need easy tools for model deployment. And this is our view at Cloudera. But it's also quite hard to do this in the enterprise, because even though you have all of the ingredients for successful machine learning, so you have the data, you have the business problem, you generally have the market leverage to actually derive value from it. You're also operating under a unique set of constraints, some of them internal, some of them external. Data can be anywhere in the public cloud, private cloud, on-prem. You can have heterogeneous, diverse infrastructure, some of it legacy infrastructure. Of course, security and governance do constrain the work that you can do. You must comply with all regulators. You have to have standards, and at the same time, be able to use the best of the open source community wherever it's most relevant to your work, while keeping those data scientists happy, because they are hard to find and retain. So this is what we do today, Cloudera Data Science Workbench, or CDSW. It's a successful product. We have hundreds of customers using it. Some of those customers have upwards of 500 users on the platform within their organization. It allows data scientists to experiment and work faster using the open source tools that they love, like Python or R. And it also keeps our IT and data management colleagues happy because it reduces risk, cost, and respects their security requirement. Western Union is an example of a customer that's using it successfully. They have a globally distributed team with hundreds of models in production. They've reduced transaction fraud below the industry standard of 1.2%. And it is available on HDP as of February 1st. So now I'm going to invite my colleague, Tristan, our CTO for machine learning, to come out and show it to you.
All right, thank you, Hilary. Let me pull this up. All right, so start your stopwatches. I want to take 2.5 minutes, 3 minutes to give you a tour of why we're so thrilled and excited to bring Cloudera Data Science Workbench, an incredibly popular tool on the Cloudera's platform, to HDP. So here I am. This is Cloudera Data Science Workbench. Number 1, nothing to install. Sign in. Wherever you are in the world, all your data scientists have access to your data science platform. Number 2, built for teams. This isn't just a notebook. A notebook isn't just enough. This is a collaborative platform for enterprise data science from research to development. Number 3, this is my favorite. Secure out of the box, never worry about Kerberos again. Isolated projects. Everybody can work on their own individual projects, use their own libraries, write their own code, collaborate with their individual collaborators. Instant access to compute on demand. Select the amount of compute you want, launch it in just a few seconds, supporting Python 2, Python 3, R, and Scala, and of course, every library that you want, including our favorite Spark. Code first and built for data scientists. We don't try to dumb down what you do. We give you all the power that you know and love, that you want, right at your fingertips, with access to the data and with access to the compute. Combining the best of code and the best of notebooks in one simple interface. But we go beyond just the development phase. There's more phases to the data science workflow. Once you have your code, we want to give you a principled way to train your models and track all the inputs and outputs, experiments. Here's an experiment, ran a few minutes ago. The inputs to my model, the outputs, the performance of it, the serialized model, the pickle file, the PMML file, the Onyx file. It doesn't matter whether you're using Spark, whether you're using TensorFlow, whether you're using scikit-learn, or whether you're using your favorite package in R. It's all available to you here and tracked. Once you've found that perfect model, well, it's probably not going to be perfect tomorrow, so you need to schedule something. 1 or 2 clicks with jobs, and schedule your nightly training run. It's scheduled. Kick it off in 1 click. It's finding the available resources. It's running that jobs. And of course, finally, you want to go beyond batch. You want to go to real time. You want to go back to the edge. So with models, not only can you deploy to the edge into Cloudera Dataflow or Apache NiFi, but you can deploy as a RESTful microservice. You can package up all that code with the models feature and deploy your model as a real-time microservice. Here's that same code now running as a model, multiple versions, monitoring, and of course, this actually works. It's real time, it's online. I can send it some code and get that prediction back in just a few seconds. So that's the kernel of Data Science Workbench, now available on HDP. Develop, train, deploy, all on one unified platform. And most importantly, that's just getting started. So to tell you what's next, I'll give it back to Hilary Mason.
Thank you. Thanks. So we're pretty excited about this, but I didn't want to leave without telling you what's coming next. So if we think about the near future workflow for data science, we need data scientists to have an end-to-end consistent workflow for the entire machine learning lifecycle, built for large teams that may be developing thousands of models across petabytes of data on an enterprise platform that's built for the cloud. And so yesterday, Mick showed you CDP, the Cloudera data platform. Today I'm going to tell you a little bit about MLX, the machine learning experience on the enterprise data cloud. Now, this is an experience that provides cloud-native machine learning, the same open source tools for building those data science, ML, and AI applications such as Python, TensorFlow, Spark, and one platform that integrates and sits alongside our data warehousing, data engineering, and data in motion offerings. And it's cloud native, which delivers many benefits specifically for industrializing AI. Containerized multi-cloud portability, rapid provisioning and auto-scaling, automatic dependency management, native GPU support, no Spark clusters to manage, and it makes happy robots with one single control plane, a single machine learning workflow built across multiple clouds. We believe that this is the technology we need to solve those challenges that keep us from fully industrializing AI today, and it's going to be a very exciting year. Thank you very much. If you want to hear more, you can visit us at the Cloudera Fast Forward Labs and Machine Learning booth on the expo floor.